All right, this is the second attempt at trying to record the final review. Sorry for getting it out so late. I was distracted with my own studying and kind of completely forgot that I needed to re-record this. But here it is now, and hopefully it'll still leave you some time to study. So we'll start with the two reviews that she had, and that's all we really had time for in the in-person session. But if we have some extra time, we can go to the Quizlet as well. But we'll start here. And so at the very beginning, we have our four colligative properties equations. So we have the vapor pressure lowering, boiling point elevation, freezing point depression, and the osmotic pressure. So if we start at vapor pressure lowering, the equation is the total pressure equals the mole fraction times the partial pressure, or the vapor pressure of the pure solvent. And so the P0 will be given to you, and you'll have to calculate the mole fraction using the moles of whatever you're looking for divided by the total moles. So it'll be pretty easy to determine what you need to divide in order to get the mole fraction. But that's really the only calculation you need to do for this, besides multiplying it by whatever value they give you for P0. And then boiling point elevation and freezing point depression, they're both the exact same equation, just with the different base values. But the molality is what you're going to need to calculate in this. So that's the moles of the solute versus the kilograms of the solvent. And so you'll calculate that and then multiply it by your constant, which is given in the equation. And then you'll have to add that for boiling point and subtract that for depression. And then osmotic pressure, pi equals MRT. Here, molarity you'll have to calculate. Temperature you'll have to convert from Celsius. And then the R will be given to you. It's a memorizable value, but it'll be given to you in most problems. Should be all problems, actually. And then pi is what you're solving for. So you'll have to calculate the molarity using moles of solute over liters of solution, and then change the temperature into Kelvin, and then multiply them all together to get your osmotic pressure. And remember, if you have the Van't Hoff factor, if it's an electrolyte, then you have to multiply it by the amount of ions in the compound. It should be like one problem on the exam about a Van't Hoff factor, so it's not that big a deal if you can't remember how to do it. But it is something to keep in mind and try to remember so that you can get that one problem right. Then we have kinetics, which is where things started to pick up for the semester. Rate, the first order reaction is K of X, so you have one reactant. And then the second order is Kx squared, or K times X times Y. And remember, anything in the brackets is the concentration of. So this is the concentration of X, this is the concentration of Y. And then the third order reaction will have three. So it'd be Kx and then Y squared, or Kx squared, Y squared. And then we're not really going to do anything over a third order reaction this semester. So these are the only three you need to remember. And then if you remember, we had the linear plots of each of the ordered reactions. Don't remember any questions about it, but she can always throw one in there, or well, I guess whoever created the test, because this isn't her test. But it'll just give you a picture of a graph with a plot on it, and you have to say, okay, that's a first order reaction, that's a second order reaction, or that's a third order reaction. Keep moving on. Reaction quotient Q is equal to KF, KR equals C, C, D, D. Okay, that's just reactant or products over reactants. And that's the definition of equilibrium. Honestly, I don't remember anything like that being on the final exam last year, so don't stress too hard about this. Q is equal to Kc, which is equal to the equilibrium constant. Gas phase, Kp equals Pc. Don't remember anything about that on the exam. Okay. And then the pH. This is something I would recommend studying very heavily for the exam because there's a lot of different problems that can be asked about pH. You can ask about pH of strong acids, pH of weak acids, pH of salts, buffers, titrations, all of it. We're not going to be doing any practice problems in this SI session. I'm going to leave that up to y'all. Just because I don't have the time to go through every type of practice problem. But I am going to explain the basics of every topic, and you can use that to help you have better understanding as you look up your own practice problems. You really can just type in pH of strong acid practice problem and it'll give you a whole bunch. So, but for a neutral solution, the pH is 7. For an acidic solution, the pH is less than 7, and a basic solution, pH is greater than 7. The pH scale, pH is equal to the negative log of the H plus concentration, and then the pOH is equal to negative log of the OH concentration. And pH plus pOH is 14. And then of these, if you remember the buffers, you can use the Henderson-Hasselbalch equation if you memorize that. If you don't, you can do them all the exact same way. You just have to kind of see where certain patterns come up for each type of problem. But I would definitely recommend doing at least 2, maybe up to 5 of each of these to help you prepare for this exam, because it is one of those things that you just really need to know how to do. And then we'll move on to the second final exam review. KSP is equal to the solubility product constant, which is equal to okay. So yeah, you can have 2 problems using KSP. You can determine KSP from solubility or determine solubility from KSP. She'll give you both on the final exam, so be prepared for that. You have the precipitation reactions and then the common ion reactions. So when you have a common ion, like it describes down here, if you're think of it as if you're trying to make some sweet tea and it's already got a good bit of sugar in it, but you want to make it chicken express sweet tea. The more sugar you put in, the more is going to precipitate out of solution because there's already sugar in there. It's already sweet tea. So when you try and add more sugar, it's not going to be able to dissolve as easily. And so when you have a common ion, like the sugar, the solubility will be decreased. And then if Q is greater than K, precipitation occurs. Those are values you'll calculate or be given. Lewis definition, this is another thing I would recommend going over very well, acids and bases. That's kind of the baseline for most of the chemistry equations she'll ask, besides the ones we've already covered. This is kind of a good chunk of the exam is acids, bases. So, and then the Lewis acids and Lewis bases is really the only ones you need to remember the definitions for. So Lewis base is an electron pair donor and Lewis acid is an electron pair acceptor. The coordinate covalent bond is both the electrons and covalent bond are donated by one atom. That's just the definition. I don't remember covering that last year. But if it's on here, it's probably going to be in the exam, at least one question. So I would just kind of keep that definition in mind. Also be sure to look up what are they called? Conjugate bases and acids. Those are a decent chunk of the exam as well. And that will help you gain better understanding for when any acid-base problem is asked. Complex ions. You can look up a picture if you need more information on that. It's kind of hard to explain in words. Thermodynamics. Yes, this is another big part of the exam, just this whole unit in general. I mean, there's 3 pages covered for it on the final review, so I can assume it's going to be a big part of your exam. So a spontaneous process occurs without any outside intervention, and a non-spontaneous process requires energy input. And if you remember, which one is it? Spontaneous was Gibbs free energy. Yeah. So if Gibbs free energy is less than 0, it's going to be spontaneous. If it's greater than 0, it's going to be non-spontaneous. But then we're looking at the first law of dynamics and then how it relates to enthalpy, which is the energy of heat. And delta H is equal to final minus initial, a very basic state function. But the important thing to remember is if delta H is less than 0, it's exothermic, so it gives off energy. And the way to think of that is if you see it, it'll be delta H is equal to -2, let's say. Then it's losing 2 energy. And so if it's losing 2, then it's exothermic. But if it's gaining 2, it'd be +2. And that's greater than 0, so that would be endothermic because it's gaining energy. Reversible process. Change system is made in such a way the system can be restored to change. Okay, yeah. So a system at equilibrium is a reversible process because it has that double arrow. It can go either way. And then an irreversible process is something that's not at equilibrium. It can't go back to the original state that it was at. So the products can't go back to the reactants. Okay, so S is equal to entropy. That's all you really need to know about it. Well, besides entropy means disorder, if you didn't know that. You don't really need to know the actual definition. Just know that S is equal to entropy, the state function, final minus initial. And then this is the important part. Delta S greater than 0 is a favorable reaction, and then delta S less than 0 is unfavorable reaction. This is a really easy problem. Yeah. Excuse me. She'll probably include on the exam. As far as I remember, these problems, it literally just says this is the entropy in the system. This is the entropy in the surroundings. What is the universal entropy? You just add those numbers together and you get it. It's a very easy problem. I don't know why they keep including it on exams. But we'll move on. The entropy of a perfect crystal at 0 Kelvin is 0. Yeah, that's the third law of thermodynamics. I do remember at one point she might ask, or the exam might ask, it'll give you a definition of one of the laws of thermodynamics and you have to pair it up with which one it is. So it might say, which law of thermodynamics covers the law of conservation of energy? And that's the first law of thermodynamics. And you might have to do that with, one or two of them. It shouldn't have a problem, but I can imagine it being difficult to memorize the definitions of each one, but just do your best on that. The Gibbs free energy, that's what's going to be, there's probably going to be 3 or 4 problems specifically about Gibbs free energy, just this one part of the entire thermodynamics chapter. So Gibbs free energy, remember that's where they're going to give you the chart and it has the values for delta G, delta H, and delta S, and you just have to plug them into this equation. Do remember that you have to convert delta S into kilojoules and then multiply it by temperature so that it'll be in the same units. And then you just solve quickly for delta G, calculate data in table. Yeah, the data in tables, products, minus reactants. Okay, that's an important fact to remember. At equilibrium, delta G is equal to 0 and Q is equal to K. And that's what produces this equation. I've never used that equation. I never remembered to use it. And I got along just fine. But they might ask something about the equation itself, like a question about the equation. Oxidation, loss of electrons. Oh yeah, and then redox reactions. Highly recommend you go do that. There will probably be 2. There could be 1, but it's going to be a multiple part problem. That's going to take up a lot of time if you don't know how to do it. And it's going to be a lot of points. I highly recommend you go look up how to balance a simple redox reaction. Remember, losing electrons is oxidation, gaining electrons is reduction. Be prepared to balance simple. Yeah, be prepared to balance simple redox equations. So she's telling you it's going to be on there. The amount of electrons you lose has to equal the amount of electrons you gain. Remember that for when you're balancing. Know how to determine the oxidation states. If you remember that, usually we're going to be doing that with oxygen. and oxygen always has a -2 oxidation state. So whatever's paired with the oxygen has to cancel out however many oxygens there are so that the final oxidation state is equal to the number on the end of the compound. I realized that just didn't make sense. So I'm going to look up silicon dioxide. SiO2. Okay, here we go. So just look at the all the oxidation problems will be presented just like this with only the compound name. So if we look at this, oxygen has a -2 oxidation state. That's just what it has. So -2 times 2, because you have 2 oxygens, is -4. So silicon needs to have a +4 charge in order to equal 0. Because usually if there was a charge on this atom, or a charge on this compound, there would be a number right here telling you what the charge is. Since there isn't, that means that this charge is 0. Let's say it had -1 up here, then you still do the same thing. It's -2 times 2 is -4, but then it has to equal -1. So this needs to be +3. So +3 minus 4 is equal to -1. So that's how you do oxidation states. And then the anode and cathode. Remember, anode is where oxidation occurs because they both start with a vowel. Cathode is where the reduction occurs because that starts with a consonant. And then whichever one oxidation occurs, the reducing agent. Whichever one reducing occurs is the oxidation agent. It's confusing, I know. And then cell potential. This is the cathode, anode. It'll give you the values on a table and you just plug them into the equation. So other than that, that's really mostly it. If you have any questions, email or send me a text or a reminder or whatever. I will try to answer as quickly as possible. I know it's a crazy week for y'all. It's a crazy week for me as well, but I'm trying to be as helpful as y'all. I'm trying to be as helpful to y'all as I can be because I remember last semester I um, was struggling quite a bit. I had a high B, but for me, I needed to get an A so I could go on to become the SI. Um, and I remember the SI session that was held really helped me get everything I needed to have for the final so that I could do good on the exam. And so I wanted to offer you all the same courtesy that I got offered last semester. So if you need any help at all, just send me a text or an email or anything, and I'll help you out as much as I can. So with that, I hope anyone who watched this has a good rest of their day, and goodbye.